Right, chapter 2, section 2, using inductive reasoning. We're covering inductive and deductive reasoning. Last class, we covered our statements, conditional statements, with the 4 of them. And by conditional, we're still working on statements and reasonings for this chapter. Conjecture is an unproven statement that is based on an observation. So basically, it is an observation that you're looking at. So you guys have observed me sitting at my desk, walking over here. Your observation could be when Miss Chung sits in the back of the room, she's going to start doing notes. So that's an observation that you guys make. Okay, that's just an observation you're seeing. It doesn't mean it's always going to happen. Inductive reasoning is based on a pattern. Okay, a process that includes looking for patterns and making conjectures. So when I'm looking at patterns, okay, if I'm going up by numbers, that's technically a pattern. So we're going to look at other examples that have to deal with patterns. So if I was going, 2, 4, 6, 8, what would my pattern be if I'm looking at these numbers? I'm adding by 2. Okay, adding by 2 could be a pattern every time. So that's inductive reasoning. It's based on a pattern that we can observe. All right, looking at example number 1. Describe how to sketch the 4th figure in the pattern, then sketch the 4th figure. So when I'm looking at this figure, let's make some observations about the figure. Okay, looking at it, looking at my shapes, what can we tell? How many sections are there in my shape? So looking at figure 1, I have 2 sections. Looking at figure 2, I have 4 sections. Looking at figure 3, I have 6 sections. And then I have to have figure 4. How many sections do you think I would have for this one? 8 sections. Good. So I'm going to have about 8 sections. 8 sections. So what is my pattern looking at this? What patterns could we have? 2. Okay, adding 2. Okay, adding 2. So yeah, I could add 2 to each. Multiplying 2. When you're saying multiplying by 2, what am I multiplying by? What number by 2? What number? Yes, multiplying by 2 could be 1, but what am I multiplying by 2? Yeah.
So figure 3 times 2 is 6.
Good, so I'm multiplying my figure number, correct? So this could be like 1 times 2 would give me 2 sections. 2 times 2 would give me 4. 3 times 2 would give me 6, and so on. Or yeah, I'm adding by 2. So I started at 2. Adding 2 would give me 4. Adding 2 would give me 6. So that's what it is. Now it wants me to describe. Okay, how would I describe my pattern? We kind of already stated it, describing it. So it says each figure, we could write it this way. Let me actually write it in white so you could see it. Each figure increases by 2 sections. Okay, so one student says they increase by 2 sections. Or another way we can write it is each circle is divided into twice as many regions as the figure number. Okay, so it's divided into twice as many regions as the figure number. So yes, technically that would be you're multiplying by 2 per figure number. Another thing we're forgetting is the highlighting. So if we're looking at it, looking at how we're observing it, we can see that it's highlighting the middle triangle. Okay, it's like the kind of like the middle triangle to the left. Okay, so it's always kind of highlighting that section right there. Forgot my S. Looking at example number 2, it says describe the pattern in the numbers 5.01, 5.03, 5.05, 5.07. Write the next 3 numbers in the pattern. Can anybody tell me what my pattern is? Hernan?
Plus 0.02.
Good. So this was a pretty easy one. You're just adding 0.02. So what that means is I'm going to take that last number, 5.07, add 0.02. What would I get?
5.09.
Good, 5.09. So what would my next number be? 5.11. And my third one?
5.13.
Good, 5.13. And then we could continue going on and on and on if we wanted to. But they're only asking for the next 3 numbers. All right, example number 3. Numbers such as 3, 4, and 5 are called consecutive integers. Make and test a conjecture about the sum of any 3 consecutive numbers. So the sum of any 3 consecutive numbers means I'm going to be adding 3 numbers. So let's go ahead and find some numbers that we're going to add. I like to start out with smaller numbers because they're a little easier. So I have 1 plus 2 plus 3. If I add them, what are they going to give me? 6. Okay, we can't really observe anything about this pattern. So we're going to go ahead and try something else. Let's go ahead and use the next 3 numbers, 3, 4, 5. If I add them, what would that give me?
12.
Good, it would give me 12. Can we notice anything? Is there a pattern?
Yeah.
Yeah?
The sum is plus 1.
Good. So if we're looking at it, okay, we're using the middle number. We're using the middle number and doing something to it. We are multiplying the middle number by 3. So if you didn't see it, I'm going to go ahead and do another one. Here's 100. I'll use a little bit of a larger number. And 102. If I'm adding, I'm going to get 303. So again, using the middle number. If I multiply that middle number by 3, it's going to give me the same answer. 4 times 3, 101 times 3, it's going to give me that same number. So I'm giving an observation. So it's asking me to make a conjecture. So looking at this, what would my conjecture be? I'm going to write it down. Something along the lines. The sum of any 3 consecutive integers is 3 times the second number. So I'm still trying to find some sort of pattern. So yes, looking at it, if you're using the third number, you can find a pattern. Any questions on example 3? No? Okay. All right, counterexample. What is a counterexample? Please pay attention to what a counterexample is. A counterexample, to show that a conjecture is false. Just one example for which the conjecture is false. Okay, so all you need for this is you need to give me one example to prove that my conjecture is false. So please make sure you understand how you're showing me this. An if-then statement is false if an example can be found for which the hypothesis is true and the conclusion is false. So looking at the example that it's giving me, keep in mind your hypothesis is what comes first. So we had our P's and our Q's. So this is my P, here is my Q. Find a counterexample. If you live in Florida, then you live in Miami. Is that true? No. So what would a counterexample for this be, Christian?
If you live in Tallahassee, then you live in Florida.
I'm not switching it. I'm keeping it the same. I'm just changing my conclusion. I'm trying to prove my conclusion to be false. Yes. It's very broad. Yes, Matthew. I'm sorry, Sean.
If you live in Miami, you live in Florida.
So I'm not switching it. I'm still keeping my hypothesis true.
I wouldn't it be the one that you said, like if you live in
because it's still true.
Must be false.
If you live in Florida, it's still true. It's a counterexample. I'm trying to prove it false. So why would this statement be false? If you live in Florida, then you live in Miami. That's not true. Go ahead.
If you live in Florida, you live in Fort Lauderdale.
Thank you. If you live in Florida, you could live in Fort Lauderdale. You're thinking of other things that would make this statement false. So I'm keeping my hypothesis. It's still going to be true, but I'm trying to prove the conclusion false. That's what I'm trying to prove. So examples to make this statement false would, yes, if you live in Florida, I could also live in Davie. I could also live in Fort Lauderdale. I could also live in Weston. I could live in Cooper City. Okay, I could live in Pembroke Pines. I could live anywhere else in Florida, but that does not mean I'm necessarily living in Miami. So yes, majority of people associate Florida with Miami, but that is not the only place you can live. You could live in Orlando, Tallahassee. Where else is there? West Palm Beach, Delray, Daytona. There's a lot of other places you can live in Florida, but you don't necessarily mean you live in Miami. Does everybody understand what counterexample is? You're just trying to prove the second statement to be false. All right, so looking at this example, it says find a counterexample. A student makes the following conjecture about the sum of two numbers. Find a counterexample to disprove the student's conjecture. So what it says is the student believes the sum of two numbers is always more than the greater number. Is that true? No. So can someone give me an example to make this statement false? Yeah.
Does it have to be counterexample for
Just give me an equation. How would I make this false? How can I prove?
plus -3?
Okay, so let me write that one down. If we had 5 plus -3, what would I get? 2. Okay, 2. Is 2 greater than 5? No. Okay, another one is adding two negatives. -2 plus -3. That would give me a -5. Is -5 larger than -2? No. So there are multiple ways that it can prove this statement to be false. So when you're proving something false, that's called a counterexample. I proved it false. So looking at it, because a counterexample exists, the conjecture is false. Okay, so I just proved the conjecture to be false using a counterexample. All right, deductive reasoning. We did inductive reasoning. Again, inductive has to do with a pattern. Deductive has to deal with facts. So now we're looking at facts. Okay, what are facts? They're things we know to be true. Things we know are true. Okay, deductive reasoning has to do with facts. Inductive, like we did in the other examples, has to deal with a pattern. Okay, when we're dealing with deductive reasoning, there are two laws of logic, and we're going to go over those two. And yes, you have to memorize what those two laws of logic are. All right, the first law is law of detachment. Okay, law of detachment. Before we look at it, just listen to that word. It says to detach. So when I think of law of detachment, I think of I'm separating something. It says if the hypothesis of two conditional statements are true, then the conclusion is also true. So here's my hypothesis. Here's my conclusion. And now I'm going to look at it. All right, so looking at this, keep in mind that arrow is giving you the order it goes in. And it says, if it's Friday, then I eat pizza. So that's my true conditional statement. Okay, if it's Friday, then I eat pizza. now I'm going to break it up. Technically, I like to think of it again as I'm going to detach it. Today is Friday, so my conclusion is I will eat pizza today. Okay, so again, my conclusion is if it's Friday, then I eat pizza. That's my conditional statement. That is my true statement. I'm detaching it and saying today is Friday, so I will eat pizza today. It's separated, not in an if-then format. Okay, I'm separating it. I am detaching those statements. That is law of detachment. So the next law that you have to know is law of syllogism. So looking at law of syllogism, used when the conclusion of one of the statements is the hypothesis of the other. So pay attention to the colors, the reds and the blues and the greens. I'm giving you two statements, two true statements. It can be written as one statement. If the hypothesis of P, then the conclusion of Q, then I'm starting it again, then the conclusion of Q. If the hypothesis of Q, then the conclusion of R. So I'm technically getting rid of that middle part. I'm not separating anything. I'm blending it together, or I'm taking out the overlap. So looking at the example in the next slide, it'll most likely make sense. This again is a law of syllogism. Detachment is when it's separating it. I am not separating it. I'm blending it together. So looking at this example, law of syllogism, it says given two true conditionals, write a new conditional statement. So look at what it's giving us. If it's Friday, then I go to the movies. If I go to the movies, then I eat popcorn. And my conclusion is, if it's Friday, then I eat popcorn. So what am I getting rid of? I'm getting rid of this. Then I go to the movies section. If I go to the movies, I'm canceling out what's overlapping. Or you could think of it as blending it together. So I'm getting rid of this. Okay, so again, you could think of it as blending together, or take out the overlap. Alright, so what I'm keeping is that if it's Friday, then I eat popcorn. That's the section I'm keeping for my conclusion. All right, looking at example number 5, it says if 90 degrees is less than the measure of angle R, which is less than 180 degrees, then angle R is obtuse. The measure of angle R is 155 degrees. Using the law of detachment, what statement can you make? So what would my statement for this be? What would my conclusion be? So again, law of detachment, what do I have? I have my hypothesis to my conclusion is the first statement they're giving me. Then I'm going to detach it. I'm going to break it apart. I have my hypothesis, and that's going to give me my conclusion in the end. So looking at it, can someone tell me what my conditional statement was? What was my conditional statement here?
If 90 degrees is measures are 180.
Okay, what else? Remember, your conditional...
Then R is obtuse.
Then R is obtuse. Good. So when I'm looking at it, this entire thing right here is my P and my Q. Okay, this is my conditional statement. Remember, detaching, I am separating it. So now look what it says. The measure of angle R is 155 degrees. That I separated. That's right here. The measure of angle R is 155 degrees. That is my P part. How do I know? Because it's what I'm finding. So what would my conclusion be? Could anybody tell me? Again, you have your if-then statement. What would my conclusion be?
If 90 and 155 degrees, 180, then R is up to.
I just need my conclusion. I just need my Q part. What is my Q part? What is it?
Angle R is obtuse.
Good, that's it. Angle R is obtuse. My conclusion is angle R would then be obtuse. So angle R is obtuse. So they're giving me what I have. They're giving me my statement, my conditional statement. Then I'm trying to prove my conclusion to be true. Okay, my conclusion is going to be true because they're giving me my measure. Is angle R obtuse? Yes. Why is it obtuse? Because it's 155 degrees. All right, looking at example number 6, it states, if Janelle gets a job, then she could afford a car. If Janelle can afford a car, then she will drive to school using the law of syllogism. What statement can you make? Can someone tell me what statement can we make using the law of syllogism? Yes.
Then she will dress.
Good. So the law of syllogism means I'm blending it. God bless you. I'm blending it together, or I'm getting rid of that overlap. So the overlap is, then she can afford a car. If Janelle can afford a car, that is my overlap. All you have to do is take the overlap out and then rewrite your new conclusion. So yes, like she stated, my new conclusion would be, if Janelle gets a job, then she will drive to school. If Janelle gets a job, then she will drive to school. Okay, so I just used the law of syllogism. All right, looking at example number 7, it says state the law of logic that is illustrated. So now we're determining which law is it. If you get an A on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. If you get an A on your math test, then you can watch your favorite actor. Which law is this? Good. Law of syllogism, how do we know? Yes.
Blending.
I'm blending it together. Okay, I'm squishing them together. So yes, this is a law of syllogism. I am, yes, blending it or take out overlap. And it is this part that I'm taking out. Okay, that is law of syllogism. You are blending them together, putting it together. All right, looking at this one, it says state the law of logic that is illustrated. If x is greater than 12, then x plus 9 is greater than 20. The value of x is 14. Therefore, x plus 9 is greater than 20. Which law is this? Which law is this? Anybody have an idea? So looking at my if-then statement, here is my if, here is my then. They're giving me the value of my x. This is the value of my x. And then they're saying because that's the value of x, therefore x plus 9 is still greater than 20, which is what they gave me in the beginning. Which law is this? Is this syllogism or detachment? Syllogism or detachment, which was it? One is it? Am I blending anything together or am I separating my statement? Yeah. It's detachment. I'm separating it. Again, where am I separating it? Right here. They're giving me my x value. Then I have my conclusion. So yes, this is law of detachment. All right, last example. It says determine whether inductive or deductive reasoning is used to reach the conclusion. Explain your reasoning. What's the difference? Can anybody tell me the difference between inductive and deductive? Yes.
Isn't inductive combining?
Is what?
Combining them?
I'm not combining them. Inductive has to deal with patterns. So deductive reasoning has to deal with what? Okay, inductive has to deal with patterns, which means deductive has to deal with facts. So go ahead, I'm going to give you a couple minutes, read A and B, and then you determine which one's inductive, which one's deductive, and how can you tell? Go ahead and work on those. All right, looking at it, we're going to go over it. It says for A, each time Monica kicks the ball up in the air, it returns to the ground. So the next time Monica kicks the ball up in the air, it will return to the ground. And the next time Monica kicks the ball up in the air, it will return to the ground. And the next time she kicks the ball up in the air, it will return to the ground. So what is that? Is that... Yes, that is gravity. But is that a pattern or a fact? That's a pattern. It's continuing. My pattern's going to continue. So this is inductive. And this has to deal with a pattern. And then looking at the next one, it says all reptiles are cold-blooded. Is that a pattern or a fact? Fact. Parrots are not cold-blooded. Pattern or fact? Fact. Sue's pet parrot is not a reptile. Okay, that is a fact. So this has to deal with deductive. And this is based on fact. Okay. You guys will have homework on this on big ideas. Obviously, there is no work. Shh, there is no work. Just answer these as best as you can. Your first quiz is this Friday. It's covering 2-1, 2-2, and 2-3. So we'll cover 2-3 tomorrow.